Yeah, we are live. Hello everyone. Thank you for watching this video. Here I am explaining my recent project. I call it Cogniflow. It is an AI for intelligent flow of thought-like processes. So basically, this means we as in user can create any combination of stack to interact with the system. So stacks, oh, system, AI, all these things. I'll be explaining them here right now. Okay, so first let's go through the overall structure, the README of this repository. We have key features like document processing. PDFs are processed, converted into embeddings, vectors, and then uploaded into ChromaDB. So later on, for any queries, the similarities can be compared and the response can be generated. There is an attractive chat AI chat interface. We have flexible workflows. User can create various types of workflows, which we'll be explaining later on. Multi-source intelligence. A user can interact with the document or with the web results in different form. So there is user management. I'm using JWT authentication for personalized query and responses, and for personalized project spaces. So every user has different space, different projects, and all those things. Real-time processing, you can see the queries response from the AI instantly, and modern UI, clean, responsive, and things like that in React.js. With key features, this is the architecture of the project. I have a front end, I have a back end, and some external services. Front end is built on React.js with TypeScript, Redux Toolkit, Tailwind CSS, Beat, and other minor components like React Router, React Flow, right? Use memorization, use callback for better optimization. In the backend, I have used Fast API with Python, PostgreSQL for storing the metadata and details of the users, messages, history, projects, etc., and Alembic and SQL Alchemy for managing the Postgres and ORM. There are some external services like OpenAI APIs, SERP API, storage as a service, one another project for storage, right? This is the overview of the architecture. Next, if we look into the front end, back end, already explained AI integration. Yeah, OpenAI is used as of now. There are two models of OpenAI used. I mean, any models of OpenAI can be used, but there are two categorizations: one for text embeddings, uh, another for the LLM, large language model. Right, with the integration of AI, there are custom workflow engines and web search integration. This is the instruction for quick setup and deployment in the local system. This is the overall overview of the code base, front end, back end, Docker YAML, these things. These are the basic things. Workflow, AI workflow, RAG only. Yeah, these things I'll explain now as SLD in SLD. High level design. Okay. High level design has three major components: front end, back end, and external services that I already explained. For file storage, I am using Pocket CDN, which is another project of mine. Pocket is storage as a service application where it gives us certain amount of storage, and we can do literally anything in that allotted storage. So I'm using this for storing PDFs. I'm storing the vectors in ChromaDB, metadata in Postgres, and actual PDFs in Pocket. Okay. Front end architecture is this, back end is this, data flow sequence diagrams for every interactions are here. Class diagram is here. You can check it out. I have explained that. Yeah, workflows types. Okay, there are one, two, three, four types of workflows. One is just LLM. User asks question to uh, AI, and AI answers it with the publicly available information that the AI knows. Like for ChatGPT, it knows everything in the internet, so it will answer it. There is this RAG plus web search. So same query will go to the RAG model, RAG stack, and to the internet, and merging the answers of results of both these two nodes. LLM will frame proper response and give it to us. Only web search, like the question will go to the internet, answer from the internet will be modified, will be framed properly, and given to us by LLM. RAG only is just RAG only is uh, the query of the user should be based on the context of knowledge base, and LLM can simply frame the answer properly. It cannot use external knowledge. All it can use is the knowledge given in the knowledge base node, meaning those PDFs. To orchestrate these different types of workflows, there is a workflow executor, which is creating the pipeline of execution, order of execution. So basically, uh, a simple idea is the context. Initial context is passed to one of the node, and the context is updated and returned back. And in the second node, the updated context is uh, given as the params, and the new context, updated context, is returned. So in this way, the final uh, context after these three nodes will be our actual answer to our query. So for authentication, I use JWT simply. That is fine. Uh, Pretty much major security measures are taken care. Password hashing, authentication, input validation, SQL injection protection, course rate limiting. All these things are implemented in the front end. Token storage is in local storage. Auto logout is not implemented. Protected routes, yes. Input sanitization, yes. HTTP enforcement, yes. Data security, API encryption, yeah. File upload validation, yes. Access control, yes. Audit logging, yes. A little bit partially audit logging is implemented. So yeah, this is the high level idea about the project. Next is overall structure is done, front end is done, back end is done. CI/CD. In CI/CD, what I have done is I have relied on the GitHub actions. Okay, you can see these are the actions that is running. This is the action that is running. So every action, whenever any code is pushed to the test branch, this action is kicked in. So it will log into ECR and build the image for the backend. It will push that image to ECR, and next it will log into the EC2, and it will pull the image from ECR, and then it will deploy the Docker container again. This is simply for the uh, backend, and for frontend, I have used AWS Amplify. Whenever any code is updated in test, the Amplify builds the image, builds the front end file again, and it is deployed there in the Amplify. That is how CI/CD is taking place. So security in CI/CD is also considered. EC2 instance has a strict security group where only a 80 port 80 443 and the port for the Postgres is exposed to public, because I have to access that database in my Postman. So I had to expose that. Otherwise, it would, I mean, ideally in production level, I don't even have to expose the Postgres port number. Nginx is taking care for the the hosting of the server, so port 80 is required. That is in the EC2 part. Amplify already has all the security and caching features. So using CloudFront and all those things is already implemented by Amplify. So I did not need to do anything. Next is code base. Now I'll show you the code base. Yes, you can see some of the scripts which are not for deploy, not for production. These are for my local setup and deployment pipelining configuration. Anyway, this is the doc that we just saw. Front end and back end both have their own README file for detailed explanation and setup instruction. And backend has a dedicated API documentation where you can see the response and request and response structure. Next, yeah, I think this is pretty much all about the code base, right? Next, we will check out the website. We'll check out the website. Website is hosted in cogniflow.balarusal.com and backend is hosted in another subnet, okay, subdomain, in another subdomain. So let's see. Simply, I'll create demo6@gmail.com. Since I have implemented only uh, auth JWT authentication, this email is does not exist. This email does not exist, but still this works. 6@gmail.com. So now we have entered into this project dashboard. There are no projects, so I'll create one project. Demo6. Demo is good. Description. So initially we create an empty project and now we edit it because the project is created but it does not know what to do. We have to design it, so we are not even able to text chat with it. So we have to design this, and that we do by creating the flow. Whenever the user has some query, the query will go to, for example, in this case, in this stack, the query goes to knowledge base and the response from the knowledge base goes to LLM. Then finally, the response from LLM goes to the user. This way things go. But to validate, to create these nodes, LLM and knowledge base node, we need some credentials. Those credentials I will be pasting here. Where is it? Where is it? Where is it? Where is it? This one. This is the OpenAI API key. And similarly, I will copy, let's say, this embedding model. Okay, there are whitelisted models, and only those whitelisted models are allowed. If these are not whitelisted, they are invalidated and this update request fails. So yeah, we have the credentials, but for the knowledge base we need some PDF, some information to restrict this LLM to answer the questions based on, right? So those things we will pass later on. For now we have created the nodes, so we will push it and you can see the response. These values and these values are done, are saved. Still we are not able to text because the stack involves the stack you can see involves KB LLM, so knowledge base and LLM. But for knowledge base we need some data, right? As I told you, this PDF, so we will upload those PDFs right now. We will upload the PDF now For example, these documents I prepared before starting this project. So now we will save it. In the backend, this is converting all the PDFs into vectors and saving it into the ChromaDB. Okay, into the ChromaDB. Now they are saved. You can see all these things, and we are getting the URLs. So these files are ultimately saved in the Pocket server, right? This is the public key of the client, and this is the key. So these files are saved in Pocket storage as a service project, and the vectors are stored in ChromaDB. Metadata are stored in Postgres. So yeah, anyway, the stack is now ready. Now we should be able to chat. So I'll ask some question like a random unrelated question. Okay, what is Ikagi? So the question is what is Ikagi, and you can see apparently it gave us 5 relevant chunks, right, from the given these PDFs, but LLM checked it and decided these are not relevant chunks, because you can see these are, you know, minor similarities are minus, so they are, you know, in at least related in some extent but not fully, because sometimes like if you know how vectors work, it checks for the similarity of the whole text. So what is three tokens, like 3 tokens, so it checks for the similarity of those 3 tokens. So somehow they gave these many similarities, but still when it came to the LLM decided these songs are still not related to the question that I have asked. So now I will ask some relevant question. What is Cogniflow? Explain Cogniflow stack. Let's see what happens to this. I'm not sure if this exact question is answered in this PDF, but still let's hope. Yes, apparently there is some relevance. Okay, so now it looks like it has given some related similar chunks, and based on that chunk, it has answered me these things. Okay, this is how the stack works. Now this stack is still completely customizable. And another thing, you can see the conversation history is passed. So whatever we are chatting initially, like since the beginning, latest 5 messages will also be passed as the context. So based on that, it will answer us. So to show that in example, what am I talking about? It should answer something. So yeah, here you can see I'm talking about this and that. Okay, so anyway, we will delete these files and save it. So now all those files are gone. So again, I'm not able to chat. Now I'll edit it again, edit and add Ikagi file, right? Ikagi file. Now I should be able to answer. It should be able to answer the question for Ikagi. Yes, let's ask the same question. Now you have to remember while passing, like even if I ask question about Cogniflow, it will answer because it is this is also the context now. So based on these 2 messages, it will answer. For now, we are asking what is Ikagi. Right, you can see this is the self. So initially it was not able to answer. Now it is able to answer because we have passed the context. Now if I ask explain Cogniflow stack again based on the message, if I am not wrong, it will answer. Based on the previous message, it will answer. It should answer, right? Let's see. Yep, it did. It did answer from initial context. Okay, this is about the UI. Okay, website is also done. Future updates. Here are many things that I have to do, like email MFA verification for while registration and login. That is very important. Next is storing the mm, OpenAI credentials in these values in the database in encrypted form. Even though the password is hashed, but these values, these sensitive credentials are not encrypted. They also have to be encrypted. That is the second update. Next update is I have to implement load balancing for the EC2 for large scale usage. And you can see the data, and you can see uh, ChromaDB and Postgres are the services in the Docker. That is not ideal for large scale production. For production, Postgres should have its own database, ChromaDB should have its own database. So in future, I have to use bigger databases, maybe AWS, RDS for Postgres, and for vector storage, something else. I have not thought about that thing I have to do. So even though this next update in the future is, even though this chat box is responsive for the mobile, it is not responsible for editing, updating these stacks that I have to think for the future. And one last update is to provide the access of these chat box, like these individual stacks. Provide these individual stacks is APIs, right? I have one stack right now which is able to answer these Ikari answers, but I should be able to create any other stack based for any specific purpose and be able to use it elsewhere. Basically, expose the API for these stacks so that anyone can use this stack in external services. That is the next future update that I'm thinking about. Better options, yes, definitely there are many better options. As I told you, Postgres, ChromaDB, better options. I could I could basically edit this header, make this UI a little bit more interesting, attractive. Even though I have implemented Redux, Redux is not properly aligned, because you can see, even if I did, what is this, spinning, those things I should clean up, make a little bit more, premium. Other better options are, yeah, I think this is it. Yeah, implementing Kubernetes, right, for orchestration of the pods, all those things I could do. I haven't done that now. So yeah, these